Welcome to Spring LIB.
Hello, in the question we have given that a child is perched at the top of a hill with her sled at a height of 7 meters above the base of the hill. So the height is given, that is equal to 7 meters. The total mass of the girl plus the sled is 36 kgs. So this mass is equal to 36 kg. So we have to ignore the friction and the resistance if there is any. So a child sits on the sled. So there is part A. So in the part A they are saying the child sits on the sled and starts sliding down with an initial speed of 0. So the initial speed we will call it as u, that is equal to 0. So how fast will she be moving when she reaches the base of the hill? So over here we have to find out the final velocity v. So we will use here the work energy theorem. So according to the work energy theorem, work done is equal to the change in kinetic energy. So we can write this as work done is mgh is equals to kinetic energy is half. So this will be kinetic energy final minus kinetic energy initial. So this is what this change in kinetic energy means. So it will be half m. Final is v square minus half m u square. But this term will go to 0 because the initial velocity is 0. So that is why this kinetic energy will be 0. So now let us plug the value. So this m goes away. So we get v as equals to square root of, so it will be square root of 2gh. So it will be just square root of, so square root of 2gh. So v from here will be equal to 2 times 9.8 into height is given, that is 7. So let us calculate this. So we get this as, so I am directly writing the final answer. So square root of 2 into 9.8 into 7 turns out to be 11.7132 meters per second. So this is the final velocity, the velocity which she come down. Now in the part B, so we have the second part. So in the second part what they are saying is that the child climbs back up the hill with her sled and brings her mother along. So at the top of the hill the child gets on the sled and her mother gives her a strong push so that the initial speed is given. So u is given to be 5 meters per second over here. So now we have to tell that how fast will she be moving when she reaches the base of the hill. So again same thing we have to do, we have to find out the final velocity. Now your initial velocity is given, that is only the difference. So what we will do is we will again use the work energy theorem over here. So according to the work energy theorem, work done is equal to change in kinetic energy. So that is equal to, so kinetic energy in final minus kinetic energy initial, that is what we know. So this work done is mgh, that is equals to kinetic energy final is half mv square minus half m u square. So this m goes away from both the sides. So we get this as g times h is equals to, so this half we can take common, so this can go over here. So it will be 2gh into v square minus u square. So from here v square will be equal to u square plus 2gh. So this is the equation of motion if one can notice. So v will be equal to square root of u square plus 2gh. So it will be square root of, sorry, This is square root of u square is 5 square plus 2gh. So it will be 2 into 9.8 into height is 7. So now if we calculate, so this will be 5 into 5 is 25 plus this 2 into 9.8 into 7 will turn out to be, so this will be 137.2. So this will be equal to square root of 162.2. So from here v will be equal to, so square root of 162.2 is 12.73 meter per second. So this is the velocity with which she will come down. I hope you find the solution useful. Thank you.